Today, we are going to dive into a fascinating scientific experiment. But before we begin, let me tell you about a legendary ship, the Titanic. It was the largest ship of its time, and people said it was unsinkable. But on its maiden voyage in 1912, the Titanic struck an iceberg filled with water, and unfortunately, it sank. This brings us to a surprising question. What if the Titanic had been built out of plastic instead of steel? Would it have floated longer? Or would it have ended up sinking in the same way? To answer this question, we are going to explore the fundamental science behind buoyancy and the density of materials. Ready to put on your little scientist's lab coat and discover how plastics react in water? Open your activity book to jot down your observations, and don't forget to ask an adult to join you for the experiments. The reason why some materials float while others sink is related to their density, a very important scientific concept. One way to explain density is by comparing this foam ball and this steel ball. Since foam is much less dense than metal, the foam ball is much lighter than the steel ball, even though they are about the same size. With plastics, depending on how the polymers are assembled, some can be lighter or heavier than water. Today, we are going to test 4 types of plastic among those you encounter most often in your daily life, using a simple, fun, and safe experiment for little chemists like you. We're going to find out which ones float and which ones sink, and try to find the material that might have saved the Titanic. For our experiments, we will use polyethylene terephthalate from a vitamin bottle, high-density polyethylene from a milk bottle, polypropylene from a garden bucket damaged by the sun, and polystyrene from a mushroom tray. Test number 1. Fresh water. Our first test consists of immersing our pieces of plastic in fresh water, a bit like if our Titanic ended up in a lake or a river. Those that float in fresh water have a density lower than 1, which is the density of fresh water. This is the case for polypropylene and high-density polyethylene. Those that sink have a density greater than 1, just like the steel Titanic. These are materials like polystyrene and polyethylene terephthalate, which are too dense to stay afloat in fresh water. Test number 2, salt water. We will now use very concentrated salt water with a density of about 1.15 to see how the plastics floating in the fresh water react. It's a bit like testing our plastic Titanic in the Dead Sea, which has a density of 1.2. Let's see what happens. As you can see, polypropylene and high-density polyethylene still float, and polyethylene terephthalate still sinks. But a small change this time. Polystyrene floats in salt water thanks to its density close to 1. Test number 3, vegetable oil. Finally, we are going to use canola oil for our last test, because this oil is slightly less dense than fresh water, about 0.92. Let's see how our plastics react. This time, only the polypropylene stays on the surface, which means that this piece has a density lower than 0.92. As for the other 3, their higher density causes them to sink to the bottom. In summary, we can observe that polyethylene terephthalate sinks in all 3 of our liquids. High-density polyethylene floats in fresh water and salt water, but sinks in canola oil. Polypropylene floats in all 3 of our liquids, and polystyrene sinks in fresh water and canola oil but floats in salt water. So, each of these plastics reacts differently. By the way, if you try this experiment at home, you might notice some inconsistencies in the results. Rest assured, it's not you who made a mistake. Not all plastics from the same family have exactly the same density, and it's the same for vegetable oils or salt water. All these small variations can therefore influence your results, so don't worry about it. On the contrary, I encourage you to write down your observations in your activity notebook.
So, let's get back to our big question.
What if the Titanic had been made of plastic? Imagine for a moment that the Titanic, its furniture, and even its cargo had been made entirely of polypropylene. In this version, funny but a bit crazy, our polypropylene Titanic might have survived a flood, always floating on the surface like a gigantic toy boat. But of course, this scenario remains impossible in reality. A real ship carries passengers, sturdy furniture, provisions, all much heavier than floating plastic. With all that on board, even a lightweight plastic Titanic would have ended up sinking because once filled with water, it would lose all its buoyancy. Thanks to this almost scientific investigation, we've discovered that each plastic has unique properties, making it perfect for some uses and not at all ideal for others. But be careful. Even though these tests are fun, plastic should never be left floating uncontrolled in nature. To learn more, grab your activity book and join me in the next video to explore more mysteries of plastic.